Okay, I hope I'm audible to all students who are attending this lecture of mathematics class 12. We continue with our lectures on probability. And if all students can recall that in the previous lecture of probability, we had done the concept of conditional probability. We had done the concept of conditional probability in the previous lecture. So let's quickly recall the formula we had done for conditional probability. If capital E and capital F are two events associated with the sample space delta of a random experiment, then the conditional probability of the event E, given that event F has occurred, is given by probability of E, given that event F has already occurred, is probability of E intersection F divided by the probability of the event F, provided that the probability of the event F is not equal to 0. This was the definition of conditional probability, which we had covered in the previous lecture. And then we had also discussed some properties of conditional probability in the previous lecture. Okay, so now in this particular lecture, let's do some more practice questions based on conditional probability. Okay, so erasing this off, let's continue with more practice questions on this particular concept. So practice questions on conditional probability. Okay, continue. We had done two practice questions in the previous lecture. We continue with the practice questions in this lecture as well. So question 1 for this lecture. 10 cards numbered 1 to 10. 10 cards numbered 1 to 10 are placed in a box, mixed up thoroughly, and then one card is drawn randomly. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? Okay, so let's solve this question. Let's read the question again. So 10 cards numbered 1 to 10 are placed in a box. They are mixed up thoroughly, and then one card is drawn randomly. If it is known that the number on the drawn card is more than 3, what is the probability that it's an even number? So first of all, let's describe the sample space of the experiment. The sample space of the experiment which we denote by delta, is the set of, so we are having 10 cards and each card is numbered from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is the sample space of this experiment, because when we are picking up the cards, when we are drawing any one card, it can take any one of these 10 values. So this is the sample space of the experiment. Now let A be the event that the number on the card drawn is even, and B be the event that the number on the card drawn is more than 3. So we have described these two events. Now what do we need to find out? We need to find out what is the probability that the number on the card is an even number, given that the card drawn has a number greater than 3. So we need to find the conditional probability of the event A, given that event B has already occurred. As per the formula, it's probability of A intersection B divided by probability of B. Now, what is the probability of B? Probability of B is number on the card is more than 3. Now, guys, what are the total number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total number of outcomes is 10. What are the favorable number of outcomes for the event B? Because all of us know probability of any event is the favorable number of outcomes in that event divided by total number of outcomes. Now, favorable number of outcomes are, now more than 3 means 4, 5, 6, 7, 8, 9, 10. So how many possibilities? 1, 2, 3, 4, 5, 6, 7. So 7 by 10 is my probability of B. What is the probability of A intersection B? So let's find this out now. Probability of A intersection B will mean what is the probability that the number on the card drawn is even and number on the card drawn is more than 3. So if I combine A and B, it means all even numbers more than 3. Now look at the sample space. How many even numbers I have more than 3? Again, students, my total number of outcomes is 10. What are the favorable number of outcomes? I need to have a number which is even and more than 3. Now, even and more than 3 means 4, 6, 8, and 10. How many possibilities? 1, 2, 3, 4. So 4 by 10. So probability of A intersection B is 4 by 10. Probability of B is 7 by 10. We know how to find the answer now. So I can now write what is the probability of A intersection B. So let's quickly write this. So our probability of A conditional on B is nothing but probability of A intersection B, which is 4 by 10, divided by probability of B, which is 7 by 10. 10 cancels and our answer is 4 by 7. This is the final answer for this question. Now what we have done is we have applied the concept of conditional probability and the formula for conditional probability. Okay, so let's now look at the second question, question 2 for this lecture. In a school, there are 1,000 students, out of which 430 are girls. It is known that out of 430, 10% of the girls study in class 12. What is the probability? What is the probability a student randomly studies in class 12 given that the chosen student is a girl. Okay, so again, let's read this question and then let's solve it. In a school, we have 1000 students. That is my sample space. In totality, we have 1000 students, out of which 430 are girls. It is also known that out of these 430 total girls in the school, 10% study in class 12. Okay, we need to find the probability that a student randomly studies in class 12, given that the chosen student is a girl. Okay, so again, let's describe the events. Let A denote the event that a student chosen randomly studies in class 12. Let A denote the event that a student chosen randomly studies in class 12, and let B denote the event that a randomly chosen student is a girl. Now, what do we need to find? We need to find what is the probability that a student chosen randomly studies in class 12 given that a randomly chosen student is a girl. So probability of A given B, apply the formula. It's probability of A intersection B divided by probability of B. Now, what is probability of B? What is the probability that a randomly chosen student is a girl? Probability that a randomly chosen student is a girl, we have 430 girls out of 1000 students. So 430 by 1000, which is 0.43. And now we need to find out probability of A intersection B. How will I read A intersection B? Student chosen randomly studies in class 12 and is a girl. So probability of A intersection B will be the probability that a randomly chosen student studies in class 12 and is a girl also. Okay, now how will I find out probability of A intersection B? Now, if you carefully look at the question, what will that be? So it is given that 10% of the girls study in class 12. Now, in totality, how many girls are there? Out of 1000 students, we have 430 girls. Out of these 430 girls, 10% of the girls study in class 12. So number of girls in class 12 is 10% of 430. In totality, there are 430 girls in the school, out of which 10% of the girls study in class 12. So number of girls in class 12 is 10% of 430. This is my favorable number of outcomes divided by total number of outcomes is still 1000. Let's look at this again. Probability of A intersection B means what? It is the probability that a student chosen randomly studies in class 12 and is a girl. Now we need to find out how many girls are there in class 12. In totality, the school has 430 girls and 10% of them are in class 12. So total number of girls in class 12 is 10% of 430. This is my favorable number of outcomes divided by my total number of outcomes is 1000. So this gives me 43 by 1000, which is nothing but 0.043. Now, what will my probability of A given B be? Probability of A intersection B, which is 0.043, divided by probability of B, which is 0.4. If I solve this, what do I get? 0.1, which is the final answer for this question. So probability that a randomly chosen student studies in class 12, given that she is a girl, is nothing but 0.1. So hoping students have understood this question and have no doubts. Moving forward to question 3. A die is thrown 3 times. A die is thrown 3 times. Events A and B are described as follows. Events A and B are described as follows. Event A is 4 appears on the third row. Event B is 6 appears on the first row and 5 appears on the second row. Find probability of A given that B has occurred. Okay, so we need to find the probability that the event B has occurred. Now, first of all, we can describe the sample space of the experiment. So now when a die is thrown 3 times, so we can write a note. If a die is thrown n times, total outcomes, I can write total number of outcomes. All students can write this formula in general. If a die is thrown n times, total number of outcomes is nothing but 6 to the power n. So therefore, if a die is thrown 3 times, what are the total number of outcomes in the sample space? Total number of outcomes in the sample space is 6 to the power 3, which is 216. These are my total number of outcomes of this experiment. Now let's look at the case. What does event A contain? So event A is that 4 appears on the third row. So now what all possibilities can A have? 4 appears on the third row means the first 2 can be 1. It can be 114. I am fixing 1 in the first place. So 114, 124, 134, 144, 145. 1 minute. 154 because 4 is fixed. 154 and 164. You can see in all these cases 4 appears in the final row, third row. Similarly, I can fix 4. I can fix 4 in the final place. And now I can start the same thing with 2. So 2 is fixed. And now I can have 1, 2, 3, 4, 5, and 6. Okay. Same thing I can do with 3. So again, I'm fixing 4. I'm fixing 4 at the final place. And now I'm starting with 3. Now I'm starting with 3. Okay. So now what I'm doing, I've fixed up 3 now. And now in between I can have 1, 2, 3, 4, 5, 6. Same thing I can do. Now I can fix up 4. And so on. I can now fix up 4 and so on. Okay. So we can do that. If I fix up 4, now 4 is in the beginning and end. comes in the beginning, and then in between I can have 1, 2, 3, 4, 5. Same thing I can do with 5 also, and same thing I can do with 6 also. So suppose I do for 5, 5, 1, 4, 5, 2, 4, 5, 3, 4, 5, 4, 4, 5, 5, 4, and then we have 5, 6, 4. And then I can write for 6 also on the top. You can see 6, 1, 4, 6, 2, 4. 4 is fixed in the end. 6, 3, 4, 6, 4, 4, 6, 5, 4, and 6, 6, 4. So these are all my outcomes in A, event A, where 4 appears on the third row. How many I have? If I look at the first row, it has 1, 2, 3, 4, 5, 6. And how many rows I have? 1, 2, 3, 4, 5, 6. So that means event A has 36 outcomes in total. 6 times 6. If you count them, it comes out as 36. Now let's look at B. 6 appears on the first row and 5 appears on the second row. So if I write B, 6 should appear in the first row and 5 should appear in the second. So 6, 5, 1, 6, 5, 2, 6, 5, 3, 6, 5, 4, 6, 5, 5, 6, 5, 6. Again, B has how many outcomes? 1, 2, 3, 4, 5, 6. B has 6 outcomes. Now I have to find out probability of A intersection B. So if I erase the note now, what will probability of A intersection B? What will probability of A given B? Probability of A given B is probability of A intersection B divided by probability of B. Now what is probability of B? Total number of outcomes is 216. Favorable number of outcomes are how much? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 outcomes. So my probability of B is 6 upon 216. What is the probability of A intersection B? Now, how will I read A intersection B? A intersection B means 4 appears on the third row, 6 appears on the first row, and 5 appears on the second row. You can see we only have one case, 6, 5, 4. 6, 5, 4 means 4 is appearing on the third row, 6 appears in the first, and 5 appears in the second row. That means my favorable number of outcomes in A intersection B is 1 upon total number of outcomes is still 216. So now what will my required answer be? Probability of A given that B has occurred is equal to probability of A intersection B, which is 1 upon 216 divided by probability of B, which is 6 upon 216. 216, 216 cancels. Our answer is 1 upon 6. That means for this particular question, our answer is 1 upon 6. So again, all we have done is we have used the concept of conditional probability, the formula. Okay, let's move on to the next question. Question 4. A die is thrown twice and the sum of the numbers appearing is observed to be 6. What is the conditional probability? What is the conditional probability that the number 4 has appeared at least once. We need to find the probability that the number 4 has appeared at least once. So let's read the question and then we can solve it. A die is thrown twice. So what are the total number of outcomes? Total number of outcomes is, remember, when it comes to a die, total number of outcomes is 6 to the power n, where n denotes the number of times the die is tossed. In this case, a die is thrown twice, so it's 6 to the power 2, which is 36. Now let A denote the event that the number 4 has appeared at least once. Okay, and let B denote the event that sum of the numbers is observed to be 6. What do we need to find? Probability that the number 4 has appeared at least once, given that sum of the numbers is observed to be 6. Now let's define the set A and B. So A is what? Number 4 has appeared at least once. So either I can have 1 4, 2 4, 3 4, 4 4, 5 4, 6 4, or I can have 4 1, 4 2, 4 3. Then we have 4 4, which is only one option we can have in this case. So 4 5, because 4 4 is only one option. 4 5 and then 4 6. This is my event A, where you can see number 4 has appeared at least once. Now either number 4 can appear on the second die, or number 4 can appear when the die is tossed the second time, or number 4 can appear when the die is tossed the first time. So what are the total number of outcomes in A? I can say total outcomes in A are 1 2 3 4 5 6 7 8 9 10 11. What will the event B be? Sum of the numbers is 6. So 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6. Since I have 2 4, I can also have 4 2. Since I have 1 5, I can also have 5 1. What are the total outcomes in B? Total outcomes in B are 1 2 3 4 5. Can I now find probability of A given B? It's probability of A intersection B divided by probability of B. Now what is probability of A intersection B? How will I read A intersection B? Number 4 has appeared at least once and the sum is 6. So if you look at the event B, within the event B, 4 should have appeared at least once and the sum should be 6. How many possibilities? Only 2. In these two possibilities, you can see 4 has come at least once and the sum is 6. So this is probability of A intersection B is 2 divided by total number of outcomes 36 divided by probability of B. Now how many outcomes in B? 5 divided by total number of outcomes 36. So 36 cancels out. My answer is 2 by 5, which is the final answer for this question. Again, we have directly applied this formula. Probability of A intersection B, how many favorable events are there? Only 2. But total number of events 36. Probability of B, what are the favorable events in B? 5. What are the total number of events? 36. So 5 by 36. 36 cancels. Our answer is 2 by 5. Okay, and then let's look at the last question for this lecture, after which we stop. Question 5. Consider the experiment of tossing a coin. If the coin shows heads, if the coin shows head, toss it again. But if it shows tails, then the question asks you, then throw a dice. Then throw a die. Find the conditional probability. Find the conditional probability of the event that the die shows a number greater than 4 given that there is at least one tail. Okay, so let's read the question again and then we can solve it. So consider the experiment of tossing a coin. Now, if the coin shows a head, you toss it again. But if it shows a tail, you will throw a die. Okay, so we need to find the conditional probability of the event that the die shows a number greater than 4, given that there is at least one tail. So for question like these, let's describe the sample space. So how do we write the sample space of this experiment? Now the experiment is as follows. We toss a coin. You can see I'm drawing a tree, which makes it easy. The coin can give me either heads or it can give me tails. Now the question says if the coin shows a head, you toss it again. Now, once I have got a head, I toss it again. Now, either I can get the head second time or I can get a head, I can get a tail the second time. Look at this, guys. Once we have tossed the coin, either I can get a head or a tail. If I got a head, I am going to toss it again. So either I can get heads the second time or I can get the tail second time. And if I get a tail, I throw a die. Now with the tail, either I can get 1 on the die or I can get 2 on the die, or with the tail I can get 3 on the die, or with the tail I can get 4 on the die, or with the tail I can get 5 on the die, or with the tail I can get 6 on the die. So my sample space delta for the experiment is heads, tails, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Okay, so this is my sample space of the experiment. Now let us look at the probabilities. Let us now look at the probability. So very easy. When I toss a coin, I can get head with probability half and tail with probability half. Very simple. We know this. If I toss an unbiased coin, I can get head with probability half and tail with probability half. Now, once I've got a head, I will again toss a coin. So now half is the probability of getting the first head, and the second head comes again with probability half. So my answer is 1/4. Similarly, first head probability is half, and getting a second tail, getting a tail on the second throw is again half, which is 1/4. So I can say probability of getting a head is 1/4. Probability of getting a head tail is also 1/4. Now let's calculate the probabilities of these. What is the probability of getting tail and 1? Probability of getting a tail is half, and means, always remember, and means multiply. What is the probability of getting 1 on the die? Total outcomes is 6. Getting 1 is 1 upon 6, which is 1 upon 12. Similarly, probability of getting t and 2. What is the probability of getting a tail? Half. What is the probability of getting 2? 1 upon 6, which is again 1 upon 12. So likewise, what can I say? I can say that probability of getting T3 is equal to probability of getting T4 is equal to probability of getting T5 is equal to probability of getting T6. All of these are equal to 1 divided by 12. All these probabilities are equal to 1 divided by 12. Okay, now what do I need to find out? I need to find what is the probability of event A given that event B has occurred. What is my event A? So this is my event A. Die shows a number greater than 4. This is my event A. And what is my event B? There is at least one tail. This is my event B. So I can directly apply the formula. Probability of A given B is probability of A intersection B upon probability of B. Now what is the probability of B? Look at the event B. There is at least one tail. At least one tail means I can have either heads and tails, or now or means add. Remember, in probability, and means multiply, or means add. So probability of HT plus probability of T1 plus probability of T2 plus probability of T3 plus probability of T4 plus probability of T5 plus probability of T6. Because in all these cases, you can see that we are getting T at least once. Now, if I erase the question, by now all of you know the question. And if I solve this further on the top, let us see what do we get. So probability of B will be, now probability of HT is how much? 1 by 4 plus from probability of T1 to probability of T6. All probabilities are equal to 1 upon 12. All these probabilities are equal to 1 upon 12. Probability of T1, T2, T3, T4, T5, T6. And this is probability of HT. So can I add them up? It's 1 upon 4 plus 6 by 12, which is how much? 1 upon 4 plus half, which is 3 by 4. And now we can find the probability of A intersection B. If I erase this off, what will probability of A intersection B be? Probability that the die shows a number which is greater than 4. Die shows a number greater than 4. This was event A, and there is at least one tail. That means I need to have both. Number should be greater than 4 and at least one tail. So this is probability of T5 plus probability of T6. Because in this case, we have a number greater than 4 and we have at least one tail. Now T5 is 1 upon 12, T6 is 1 upon 12. So this is 2 by 12, which is 1 upon 6. So now I can directly apply the formula for conditional probability. And then we can get the final answer. So if I erase off the remaining part of the question, we can say that probability of A intersection B, probability of A given B is probability of A intersection B divided by probability of B. Probability of A intersection B is 1 upon 6. divided by probability of B is 3 by 4. So 1 upon 6 multiplied by 4 by 3. This is my answer is 2 by 9. This is the final answer for this question. So this last question which we have done, this was indeed a very important question. It was a mix of coin and die both. So this is where I intend to stop in this particular lecture. What we have done in this lecture is we have revised the concept of conditional probability again, and we have done 5 practice questions based on the concept of conditional probability. So this is where I intend to stop in this particular lecture. In the next lecture of probability, we intend to solve a few problems from exercise 13.1 of NCERT. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I stop in this lecture.